Okay, in our numbering system video series, we started with review of decimal, which is the one we're familiar with, and then we looked at at least three other different numbering systems. We looked at binary, we looked at octal, and we looked at hexadecimal. So one that was base 2, one that was base 8, and one that was base 16. And we learned if I had a decimal number, I could convert it into one of those numbering systems, or if I was in one of those numbering systems, I could convert it back to decimal. But what if I give you a binary number and I say, what would this number be written as in hexadecimal? Or I give you a binary number and I want you to say, what would this number be written in as octal? So I would like to show you kind of a trick on how we can convert between binary or convert between the numbering systems rather than always going to the decimal version. So let's start with a decimal number. A decimal number of 255 to keep this easy, and let's think about what that would be in binary. And binary, of course, has well, most of the times we use 8 bits. And the reason I use 255 is because we talked about earlier that would mean that every one of these positions, so this is 1, 2, 4, 8, 16, 32, 64, and 128. Every one of these positions would be turned on. And if you added all those numbers up, you'd get 255. So I want to say, okay, what would this be in octal? What would the number? So this is the number in 255 is the number in decimal. 8 ones is the number in binary. What is the number in octal? And what is the number in hexadecimal? How do I write it in those? Well, one way you would probably do it is, like right now, to do your octal, you would start figuring out all your numbers to go up to, by 8s, multiplying by 8s, and figure out how many times each number goes into 255 and write out your octal number, and then convert from decimal to hexadecimal. But let's say that I was given a binary number, and I've never figured out that it's 255. I've just given this binary number right here, and I want to convert it to octal, and I want to write it what it would be in hexadecimal. I can go from this binary directly to these things. Binary, remember, is base 2. Octal is base 8, and hexadecimal is base 16. But what's interesting is that these bases, 8 and 16, can be written as a base 2. What is 8? 8 is 2 to the 3rd power. And 16 is 2 to the 4th power. So these two bases can actually be written in terms of binary base. So what we can do is we can take this binary number, 1, 1, 1, 1, 1, 1, 1, 1, and we can actually divide it up into bits of 3. Since this is 2 to the 3rd is 8, we can take this binary number, start dividing it up into bits of 3. Binary, we divided it up into bits of 1. We had all these bits, 8 bits. In octal, we'll go ahead and take this same binary number, which I've written down here, and we're going to divide it up into bits of 3. So I got 3, 3, and then technically I would have a 0 there, let's say. Okay, so what I can do is I know that this is the 1, the 2, and the 4, but then I can start over. I can do 1, 2, and 4, and I can do 1, 2, and 4. And I can then have each one of these 3 bits represent my digit in my octal number. So what is this first octal number here? I have 4 plus 2. The 4 is turned on, the 2 is turned on, the 1 is turned on, 4, 6, 7. So this number is, this digit in the octal formation is a 7. 4, 2, and 1, that's another 7. This is 2 and 1, that's a 3. So I shouldn't say 377. An octal number of 377 is the same as a binary number of all 1s, and it's the same as a decimal number of 255. And you can check this if you want. You remember you have This is the ones position, this is the eights position, and this is the 64 position, right, for octal. So I would have 3 times 64 plus 7 times 8 plus 7 times 1, and you would see that that converts to 255 decimal. So what if I have this binary number, I want to write it in hexadecimal format? Well, I can go ahead and write it out here again. But this time, since it's hexadecimal, I want to convert to hexadecimal. 2 to the 4 is 16, so instead of dividing this up into 3 bits like we did in the octal, I could divide it up into 4 bits for hexadecimal. And this would be, 1, 2, 4, and then 8, and then we start over again, 1, 2, 4, and 8. And so I could get I'd have 2 digits here for my hexadecimal. So decimal format, there's 3 digits, 255. In binary, that's 8 digits that are being used. In octal, that's 3 digits. And then hexadecimal, it's only going to look like it's going to be 2 digits. 4 bits for each one. 4 bits for each hexadecimal digit, or basically a nibble. Okay, so what is this? 8 plus 4 is 12, 13, 14, 15. What is 15 in hexadecimal? If you remember, that's an F. That's the 16th digit. That's an F. And of course, these will all be filled in again, so that's an F also. So 255 in decimal is 8 ones in binary. It's 377 in octal. And it would be FF in hexadecimal. So if you're in binary, you can go to octal and hexadecimal really easy. If you're in binary, divide it by 3 bits each and figure out what the octal numbers are. If you want to go to hexadecimal, divide it up into 4-bit pieces and convert each of those to a hexadecimal number. Okay, let's go ahead and do another one. Let's do a decimal number of 341. That's decimal. I'm going to erase that. Let's start over here. Decimal. 341. Now, once I start with a decimal, I can go ahead and convert from decimal to each of the other each of the other systems. But we're not going to do that. We're going to convert it to binary, and then we're going to go ahead and go from the binary to the other two, just to show we know how to do it. So what is this in binary? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8 bits. And this is 1, 2, 4, 8, 16, 32, 64, 128. And if I go one more, I'll have 256. And I need to go that far because if I go one more, I'll have 512. That's going to be way bigger than 341. But I actually need this 9th bit here to get this to work. Okay, so 256 goes into 341 one time, right? So it'll go in there. And when I do that, 341 minus 256 is, let me calculate it out here, it'd be 85. I think I did that right. 85. So 128 does not go into there. 64 does go into there. 64 goes into 85. I'm going to take 85 minus 64. I'm going to get 21. So 32 will not go into there, but 16 will. 21 minus 16 is 5, so that does not go in there, but the 4 will. 5 minus 4 is 1, so the 2 does not go in, but the 1 does. Okay, so there's the binary number for 341. And I want now to convert that into octal, and I'd like to also see what that number looks like in hexadecimal. Okay, so what I can do is I can write the binary number down again, 1010101001. I can do that for hexadecimal too, 1010100101. For octal, I'm going to divide this up into 3 bits. And for hexadecimal, I'm going to divide it up into 4 bits. And so I'll be able to see what my digits are for each of these. A digit here, and I guess I'm going to have a 3rd digit in my hexadecimal here. Okay, so remember this is 1, 2, 4, 1, 2, 4, 1, 2, 4. And down here it'd be 1, 2, 4, 8, 1, 2, 4, 8, 1, so on. Okay, so what is the octal number? Well, I have a 1, and the 4 is turned on, the 1's turned on, that's 5. Here the 2 is turned on, so that's a 2. Here the 1 and the 4 are both turned on. Let's see, did I write this down? 1, 0, 1, 0, 1, 0, 1. Yeah, okay. The 4 and the 1 are turned on, so that's a 5. Okay, so it'd be 525. So 341 is the decimal. 10101010 is the binary. 525 is the way you write this number in octal formation. And then hexadecimal, what do we got? We have a 1, a 4, a 1 and a 4 are turned on, right? That's a 5. So that'd be a 5. And here the 1 and the 4 are turned on, that's a 5. And here the 1's turned on, it's a 1. So in hexadecimal formation, it'd just be 155. Didn't need to use any letters because we never got up to 10 to A. So decimal, I wrote it in binary, and instead of going from decimal, trying to convert that into octal, and then going from decimal to hexadecimal, I can just go from binary very easily to convert it to octal and to hexadecimal formation. Hopefully that makes sense on how to convert.